Hello everyone, welcome to this session. In this session, I'm going to discuss about the Newton's law of cooling. The Newton's law of cooling is concerned to the convection mode of heat transfer. The convection mode of heat transfer is one in which heat transfer takes place by molecular motion or a macroscopic motion. And concerned to that, the whatever the Newton's law of cooling is there, it gives the equation for the rate of heat transfer. That is given by the HAS Ts minus T infinity. In this one, the AS is given, that is the surface area we are going to consider, and that is different for the different surface areas. And for the cylinder it will be pi dl, for the sphere it will be 4 pi r square, for the cube it will be 6 a square. And how this equation is arrived and what is the statement of the Newton's law, I am going to explain further. Here the Newton's law of cooling states that the rate of heat transfer by convection is directly proportional to the surface area and temperature difference. That is the surface area and the temperature difference. The rate of heat transfer will be directly proportional. That we can write Q is directly proportional to the AS surface area and Ts minus Ta is the temperature difference. And this equation we can further write Q is equal to HAS Ts minus Ta, where H is the proportionality constant and that constant is the H is convection heat transfer coefficient and its unit is watt per meter square degree Celsius. And AS, the surface area through which convection heat transfer takes place in meter square. That already I told you that one. It is the surface area through which the heat transfer is taking place by the convection. And then Ts is the surface temperature, that is in degree Celsius. Ta is the temperature of the fluid sufficiently far from the surface, and that is also in degree Celsius. That is the fluid temperature. And here we can see that is the convection currents are taking place within the fluid, and their heat transfer we are not going to determine. This is the convection, how it will be taking place. We are taken as the example. And for the law concerned, here the surface we are going to take. From the surface, the heat is transferring to the surrounding fluid, and the fluid is having the temperature of T infinity or Ta, and the surface is having the temperature of Ts. And this is the AS is the surface area. Okay, the surface area maybe it is a square or it may be a cylinder or it may be a rectangle, whatever it may be. The surface area from which heat is transferring, that we are going to consider. Already we know that the convection is a heat transfer where the within the fluid and from the fluid surface to the fluid and fluid to the surface, where it is the heat transfer is taking place. The example of this convection. Okay, the within the fluid and from the solid to the surrounding fluid and surrounding fluid to the solid, whatever the heat is transferring, that will call as a convection. And further, here the whatever the convection heat transfer coefficient constant we have taken, and how we can determine that one, that will explain here. The convection heat transfer coefficient H is not a property of the fluid. It is not a property of a fluid, and it is an experimentally determined parameter. Usually depends on all the variables influencing the convection, such as that heat transfer coefficient is depending on these four parameters. The parameters are the surface geometry, the nature of fluid motion, the properties of the fluid, the bulk fluid velocity. Okay, on all these that parameter is dependent, and that will be determined experimentally for the particular combination of the surface and the surrounding fluid. And typical values of the convection heat transfer coefficient for the different types of the convections. The type of the convection and heat transfer coefficient are given here. The pre-convection of gases, it is varies 2 to 25 watt per meter square degree Celsius, and free convection of liquids 10 to 1000, and forced convection of gases 25 to 250, forced convection of liquids 50 to 20,000, and boiling and condensation it will be 2500 to 1 lakh watt per meter square degree Celsius. If the heat transfer coefficient is higher, the rate of heat transfer will be higher, as well as if the surface area increases, the rate of heat transfer by the convection also increases, and that we can see from this equation. Okay, here heat transfer will be directly proportional to the surface area and the temperature difference. Okay, and here H increases. The Q is given as H Ts minus T infinity. If the H increases, the rate of heat transfer increases, surface area increases, the rate of heat transfer increases for the fixed temperature difference. Okay, and that is the convection what we have discussed, the Newton's law of cooling, and concerned to that the rate of heat transfer as well as the convection heat transfer coefficient I have discussed. Thanks for watching. If you like, share, subscribe and comment.